Welcome students. So as we have read in the previous tutorial about the basic lung physiology, the respiration physiology and what basically the ventilators are, we also discussed briefly about the certain modes of ventilators, and very important thing, we discussed about the compliance of the lung. So in this part, we'll be covering about the pressure volume relationships. Now this will be going slightly fast because all the basics have already been covered. So coming to the portion of the pressure volume relationships. So let's very briefly we'll discuss about the common modes of ventilator which we read in the last class. The first one was the AC mode, which is the most common mode, where the patient initiate the breath, and as that breath is initiated, a drop in pressure is sensed and a fixed volume of air is delivered to the patient. Okay. Similarly, we have a PC mode where they have a pressure control. So the ventilator gives a fixed pressure or volume of air. Now we'll be discussing about CPAP and PEEP. So irrespective of inhalation, you are giving a fixed pressure of air. And CPAP is when it's a non-invasive. So you are using a kind of a mask. And then you have a pressure support. So pressure support is patient initiate the breath. So you get a drop of pressure in the air. But instead of fixed volume of air being given, a fixed pressure of air is delivered. So basically it's important when you are trying to wean the patient out of ventilators. Okay. So now we'll be discussing about the positive end expiratory pressures or PEEP. Okay. So PEEP, right? So PEEP is basically the positive pressure. So what does this mean, the positive pressure? So let's say we have a lung. So normally when we are inhaling or exhaling, so after exhalation there is no air, or basically the air is only in the dead space. So effectively there is no pressure. So we have a lung. Yeah, okay. Yeah, like this. So during exhalation there is, during exhalation in a normal lung, we have a, in the alveoli there the pressure is 0. The pressure is 0 atm. And this is actually, what does this looks like? This becomes like this, or what we call, it becomes shrunken, it becomes closed. So is this good or bad? So now we will see. So in a normal people, this is absolutely perfect because these patients, like for us, it's what we require. But when the patient is on a ventilator, you might not want this. You might not want that it should collapse, because you want increase in gas exchange. So gas exchange at the level of alveoli. So what happens in a PEEP? So you have a lung. So even at the time of expiration, when you are exhaling, you give some pressure. So there is some pressure, and probably let's say you have a 5 plus 5 centimeter of pressure. So what happens, this plus 5, what does this do? This keeps this alveoli open. So these alveoli remains open. So when this alveoli remains open, what happens is this does not fall. So you get a more time for gas exchange, right? So that is the importance of PEEP. So what does this do? So use of PEEP is to keep the alveoli open, and it leads to more recruitment of alveoli for gas exchange. So now we'll be discussing the pressure, volume and flow curve on ventilator and its meaning. So basically whenever we are giving any air to the patient through a ventilator, we are doing the three things. So the air will be given with certain flow, there will be certain pressure, as well as there will be certain volume. So, and all these things could be preset, but when we monitor these, we actually get to see a lot of things in these patients. So we draw three type of curves. So we have, this is known as a flow, this is the pressure, and this is a volume. So let's consider the patient is on AC mode. The patient rate is set at 14 breaths per minute. and the volume you are giving is 500 ml. Okay, the FiO2 or the percentage of oxygen which is giving, let's say the fractional oxygen is, let's say we are giving as around 50%, and the patient, you want to keep the patient with a PEEP of, let's say 5. Okay, so this is just for example I'm just taking. Okay, so just remove it. Okay. So again, now let's get to this thing. So what happens is, we have something known as a flow, we have something as a flow, we have something known as a pressure, and we have a volume, right? So what happens is, so what was the PEEP? The PEEP was plus 5. So this is, let's say here. So there will be always certain amount of pressure which will be there. When the patient initiate a breath, you will see a fall in pressure, and when you will be fall in pressure, this will be sensed, and a positive pressure will be given by the ventilator. Then this pressure will be remaining like this, and then the patient start exhaling, and this goes down to 0, right? So this is what happens. Now let's get to the flow. So at the baseline, oh sorry, this will not actually touch the 0, because the pressure is at plus 5. So this will not touch 0, rather what, it will just keep like this. Okay, I just correct it here. Okay. Now what happens when we talk of volume? So when there is no volume right now. Why? Because the patient is not breathing. Here when we see the patient has initiated a breath, a fixed volume has gone up. And how much volume? This is what you have, the tidal volume. And then what happens is, now there is a fall in volume because patient is expiring. Okay. Now let's go for the flow. What happens in the flow? Initially there is no flow. As the patient has initiated a breath, this is a positive, right? What you are getting is a positive flow. And then what happens is, at the time of expiration, when it starts, there is a fall in pressure, fall in flow. Why? Because now it's expiring, and see, it is going downwards, it is not just going to back. Why? Because the sensors are getting the flow, and then slowly it will turn to what you call as a baseline. So this is what is a basic flow pressure volume curve. So the important thing to know is, whenever we are seeing a drop in pressure like this on an AC setting, this means the patient has initiated the breath. Now let's see what happens. So I told you we always keep a backup rate. So we always have a backup rate, right? So in a backup rate, what happens? So we have this again. We will just draw the same thing. Sorry, we just draw the same thing. So we have a flow, we have a pressure, and we have a volume curve, right? So we have a backup rate. So what happened? Let's say patient actually stopped breathing. So when the patient has stopped initiated the breathing, we'll get a backup rate. So what we said was a 14. So what will happen? So here we have a PEEP of plus 5. So there was this. So instead of getting down, there we'll see a rise in pressure, and we'll see fall. Again down. So here you can see, and this will remain the same. This, very good. Yeah. And similarly, when we talk of the flow, it will go up. And here you can see here the level. Here the expiration has begun, and it will go down, and like this, go up like this, down like this, right? So this is how you get a thing when the patient is not initiating. patient is not initiating. So this is a very important terminology when we talk in terms of ventilation. So now we have learned the basic pressure volume flow curves on the ventilator and what does it mean. We'll be discussing it in the further lectures as well, that what does this actually means and other things. So on a common ventilator setting, we'll have the mode, we have a backup rate or the respiratory rate, we have a volume, we have a fractional oxygen, and we'll have a P. So let's just see how does this work. Yeah. So, and what does this affect? So we have a mode, like let's say we have a AC mode, we have a backup rate of 16. So this is a mode. This is a respiratory rate. Then we have like 500 ml. This is a tidal volume we want. Then we have speed height like 50%. So this is what is, you have a FiO2, and then we write something known as 5 or 10 whatsoever. So this is the PEEP. So this is a common thing which we write on any paper. So let's see what does this work. So in a ventilator, the respiratory rate and the tidal volume, they affects the carbon dioxide levels, while the FiO2 and the PEEP, they affect the oxygen levels. So basically this respiratory and tidal volume, they are for ventilation. Okay, so they are affecting the carbon dioxide levels in the body. Where does this actually take a difference? Since you all know, all these patients are in a ICU, so they will be always undergoing an ABG. So when the patients are undergoing the ABG, there you actually have, you see what do you want. So let's say a patient is getting desaturated, the oxygen is low, then you will think either you will increase the PEEP or you increase the FiO2. Right? I'm not saying that you increase both or when you have to do it. We have to see it. Similarly, if you are getting a PCO2 is very high, then you may actually increase a respiratory rate or you can increase a tidal volume. So similarly, these things are very important when you are dealing these patients in an ICU setting. So this becomes very important. So that is for this part of the lecture, and hope you like it. And I'll be posting the next part. We'll be discussing something more about the pressures. We'll be also discussing about the plateau pressures and all those things. So thank you.